Going. So today what we're going to do is we're going to talk about polar and rectangular forms of equations. Okay? And so first of all, we're going to talk about how you convert from polar coordinates to rectangular coordinates. Now you might be wondering, what exactly is a polar coordinate? Polar coordinates are what you graphed on those circles. Those are called polar coordinates. It's r and theta. So remember, we were given r, which is our radius, and theta, which was our angle. Okay? And we're going to convert that to the xy coordinate plane. Okay, so that's what polar coordinates to rectangular coordinates are. Okay, rectangular coordinates are xy, polar coordinates are r theta. So notice I have a little kind of a statement that might make a little more sense. So what you're doing is you're converting an r theta point to an xy point. And so how we do that should be fairly easy. Okay, we're given r, we're given theta, we plug them into these equations. Okay, my x coordinate will equal my r times cosine of theta. My y coordinate will equal r times sine of theta. And then that is my ordered pair. So you probably need to have your calculator handy. Okay, you also probably need to have your blue sheet handy as well. Okay. So real quick, it says give the rectangular coordinates for each point with the given polar coordinates. So notice here, this is the other thing too. If you don't remember what polar coordinates are, you should know that that's an angle. Pi over 6 is an angle, right? So this is your theta. R is 4. So to find x, I'm going to take 4 times the cosine of pi over 6. So using your blue sheet, okay, you should locate where the angle pi over 6 is, which you have that radian column, so you should have pi over 6. And then when you locate what cosine is, what is cosine of pi over 6? Root 3 over 2. This is where your calculator is not going to come in very handy, because your calculator is going to give you a decimal approximation, and I will not accept that. Okay? So you're going to need to make sure if it's an exact angle, you're going to have to use your blue sheet for that. So if I take 4 times root 3 over 2, that cancels and that cancels, and I've got 2 root 3. Now what I need to do is find y. So y equals 4 times the sine of pi over 6. Sine of pi over 6 is what? One half. Okay, so really my answer is y equals 2. Okay. So my ordered pair, 2 root 3, comma 2. Questions on that? This should be pretty straightforward. Okay, it's just a matter of using the two formulas. So let's look at this one. Negative 2 and then 135 degrees. Okay, negative 2, 135 degrees. Okay, so x equals what times what? Good. Negative 2 cosine of 135. So once again, 135 degrees should be on your blue sheet. Okay. Negative 135 degrees is equivalent in the cosine to?
Root 2 over 2.
Isn't it negative root 2 over 2?
Oh, yeah.
Okay. And that negative does make a big difference. So make sure you've got that. So now what's going to happen is I can cancel my 2's, and my two negatives make a positive, So x equals root 2. So now we're going to do the same thing with y. Y equals negative 2 sine of 135 degrees. Sine of 135 is actually root 2 over 2. So then now what happens is your 2's cancel, and you get y to equal negative root 2. So your ordered pair is going to be root 2, negative root 2. Questions? All right, here's another one. Now there's a reason why we're looking at this one. Because it's a negative degree. So the easiest way to do this problem is to change that negative degree to a positive degree. So we need to think about coterminal angles. And so when I think about 120 degrees, negative 120 puts me back here, right? Negative 120. That's where negative 120 is. So I need to find the positive angle. So the positive angle is going to be starting here and going all the way around. So 240. So what I'm going to do is treat that as 240 degrees instead of the negative 120. So x will equal 3 cosine of 240. What is the cosine of 240? Negative 1/2, you said? Okay. So really, x is negative 3/2. Okay. So then now, y is going to equal 3 times the sine of 240. Okay, so I've got 3 times negative root 3 over 2. So when I multiply those two, I should get negative 3 root 3 over 2. So your ordered pair is actually negative 3/2 and then negative 3 root 3 over 2. Questions? All right, so do you think we need to look at another one, or do you think you're good? Okay, this one, what would you have to do first?
Change the angle.
Change the angle to another degree, to 240 degrees. Okay? Alrighty, so now what we're going to do is we're going to look at the opposite. What happens when you're given rectangular and you need to convert to polar? Now I'm going to be honest with you, the first ones we did were easier. These are going to be a little bit more difficult. Okay? And so basically I'm converting from an xy, so I'm given an xy, and I'm converting to an r theta. So my answer will be a number and then an angle. So now how I find r is I'm going to use the square root of x squared plus y squared. And how I find theta is I'm going to take the inverse tangent of y over x. Now I'm actually going to show you a way that I like to do this where I maybe don't need to remember the formulas, where I could just look at a picture and figure it out from there. Okay. Alrighty, so let's go ahead and start with this one. Okay, convert from polar to rectangular coordinates. So the point is negative 3, positive 6. So the first thing I'm going to do is I'm going to plot that point. That's my very first step. So I'm going to go ahead and draw a quick graph. So negative 3, 6 is going to put me in quadrant 2. Okay, and so here's going to be my point. So that's your very first step. Make sure you plot the point. Now I know some of you are probably saying, well, I could just use the formula. You can run into problems with the formula when you're finding the angle. So that's why it's usually a good rule of thumb to at least plot the point, see what quadrant you are in. Okay? So now what I'm going to do is I'm just going to go ahead and make a triangle. Kind of like when I had sine and cosine. This side is 3. This side is 6. So remember, when I'm finding polar coordinates, I'm finding the radius, which is also the hypotenuse, and I'm finding the angle. So how would I find the hypotenuse in this triangle? 3 squared plus 6 squared equals, and I'm going to call it r squared. So see, that's an option. You can use the formula, but it's nothing more than the Pythagorean theorem. Okay? 3 squared and 6 squared gives me a total of 45. So r to 2 decimal places is what? 6.71. So like I said, it's actually the exact same formula as what you were given. Okay, and so then now my radius is 6.71. Now what I need to do is find the angle. So I really want to find this angle here. But I can't find the orange angle until I find this angle, the inside angle. So if I look at this triangle, 6 is the opposite side, 3 is the adjacent side. So what ties in opposite and adjacent? Tangent. So the tangent of this angle, we'll call it theta, is going to equal 6 over 3. So basically the tangent of theta equals what? 2. So then now, in order to solve that, you need to take the inverse tangent. So you should notice inverse tangent of y over x. That's where that's coming from, that formula. What does theta equal? 63.43. Did somebody else get that?
Take the inverse tangent of 2.
Yep. So that means this angle right here is 63.43 degrees. But I don't want that angle. I want the orange angle. So
Take that times 180.
take 180 minus 63.43.
Wait, what's 63.4? That's that little.
The one right here, the red one. Okay, so 180 minus 63.43 should be 116.57.
5.7.
So my answer will be 6.71 and then 116.57 degrees. Now you can use the formulas. The problem is, with the formulas, if you're in quadrants 2 and 4, you run into, in quadrant 3, you run into problems. The formulas work great if everything's in quadrant 1. Okay, but if it's in some of the other quadrants with the negatives, that's where you can run into some problems. That's why I suggest you plot them out. So let's look at another one, and then that'll be it for today. Okay, so the point is at 1 root 3. So the first thing you're going to do is you're going to plot that. And once again, this is in quadrant 1, so everything's going to be hunky-dory here. So I have 1 here. So 1 root 3 would probably be about right here. Okay. So let's go ahead and draw that in. So I have 1, and then I have root 3. So I need to find the hypotenuse. So to find the hypotenuse, I'm going to take 1 squared plus root 3 squared equals r squared. So I have 1 plus 3. What's 1 and 3? 4. So r equals what? 2. Now you should notice this is actually a special triangle. Okay. Does anybody recognize what triangle this is? 30, 60, 90 triangle. So what would the red angle actually be?
Not 2.
60. Okay, if you didn't catch that, okay, it's opposite the root 3. Okay, and then the side opposite 1 is also 30. So you could recognize that theta is 60. If you didn't recognize it, that's fine and good because you can go through. You've got your triangle here. So remember, I could go tangent of theta equals root 3 over 1. And when you do that, you'll get 60 to work out as well. So your answer is actually 2 and then 60 degrees. Okay? So it should be pretty straightforward. Biggest thing you need to remember is you've got to plot the points. So what I need you to do in section 9.3 is I need you to do 2 through 24, the evens on page 557. Okay, 2 through 24, the evens, page 557.